Hello all. So today we'll be seeing the solutions for inverse trigonometric functions class 12, and we'll be looking at the NCERT solutions. So our first exercise is exercise 2.1. So let's see the solution. So our first question is find the principal value of the following, and we have this much set of questions. So in this video we'll be solving the questions from 1 to 5. And the next part will be solving the questions from 6 to 10. So let's solve. So the first question is sine inverse of minus 1 by 2. So first of all, we make an assumption sine inverse of minus 1 by 2 is equal to y. So we can write it in this form: sine y is equal to minus 1 by 2. That is, we bring the y towards this side and we take this minus 1 by 2 to this side. So we can write it as sine y is equal to minus 1 by 2. So we can write sine pi by 6 as 1 by 2. But in this question we have a minus in this side. So if you put a minus in the left hand side, it will be equal. We know that sine is an odd function. So it can be written as sine of minus pi by 6. The minus in front can be written to the variable as sine of minus pi by 6 is equal to minus 1 by 2. The value of y will be equal to minus pi by 6, but before going we'll be checking the range, which is minus pi by 2 to pi by 2 for sine. So the principal value is sine inverse of minus 1 by 2 is equal to minus pi by 6. The value of minus pi by 6 lies between minus pi by 2 to pi by 2. So this is the principal value for this question. So next is cos inverse of root 3 by 2. So here we don't have any negative, so we do the basic assumption, which is cos inverse of root 3 by 2 is equal to y, and then we can write it as cos y is equal to root 3 by 2. Okay, so to get the value of root 3 by 2, the value of y should be equal to pi by 6. So the value of y will be pi by 6. So checking the range, which is from 0 to pi for cos, we know that this value of pi by 6 lies between 0 to pi. So the principal value is pi by 6. Next is cosec inverse of 2. So this is a basic assumption: cosec inverse of 2 is equal to y. So in order to get this value 2, we should substitute the value of y as this value, that is pi by 6. So the value of y will be equal to pi by 6. It lies in the range minus pi by 2 to pi by 2 minus of 0. So this is our principal value for cosec y. So the principal value of cosec y is pi by 6, which lies between this range, and its value is not 0. So this is our principal value. Next is tan inverse of minus root 3. So this is a basic assumption which we do. We do have a negative over here. So let's see. Tan y is equal to minus root 3. So this is also an odd function. So before that we have a minus root 3 over here. We know that the tan pi by 3 is equal to root 3. So we put a minus in front both the sides. This is an odd function, so it can be written as tan of minus pi by 3 is equal to minus root 3. So the value of y will be equal to minus pi by 3. So taking the range, which is minus pi by 2 to pi by 2 for tan, and this minus pi by 3 lies in this range. So the principal value is minus pi by 3. Next is cos inverse of minus 1 by root 2. So we do have a negative over here. So let's see. Let's assume this value cos inverse of minus 1 by 2 is equal to y, and then we can change it as cos y is equal to minus 1 by 2. So as seen earlier, we do have minus over here. So if you put a minus in front, we can substitute the value of minus of cos pi by 3 is equal to minus 1 by 2. We know that cos is an even function. It cannot be written in the form just like sine. So we'll be giving it as cos of pi minus pi by 3 is equal to minus 1 by 2. This value of pi is this theta, which is this value over here. So will be 3 pi minus pi, which is 2 pi by 3, which is minus 1 by 2. So the value is 2 pi by 3, and the range is 0 to pi. So this 2 pi by 3 lies in this. So the principal value is 2 pi by 3.